In this presentation, we are going to learn about the spectral series of hydrogen atom. The spectral lines of hydrogen atom are grouped in separate series. These series are named as Lyman series, Balmer series, Paschen series, bracket series, and Fund series. The wavelength of each spectral line in each group, each series, they can be calculated by using the following formula. That is 1 by lambda is equal to capital R in bracket 1 by n square minus 1 by m square, which is equivalent to nu bar, where nu bar is known as wave number, which is the inverse of the wavelength, and R is known as Ricbert constant, whose value is 1.097 into 10 to the power of 7 meter inverse. Nearby, the energy level diagram of the spectral series of hydrogen atom is shown there. In this presentation, we are going to learn about the spectral series of hydrogen atom. Hydrogen atom, it has, when the excited electron in the hydrogen atom, when they jump from any other outer orbits to the first orbit, these spectral lines are emitted. These group of spectral lines are called as Lyman series. These spectral lines, they will lie in ultraviolet region. Now I am going to teach you how to calculate the wavelength of the spectral line and wave number of the spectral line in all the 5 series. Look at the general formula. This formula, nu bar, that one gives you the wave number of the spectral line. Wave number is nothing but number of waves present in the 1 meter length. Otherwise, it is also called as reciprocal of the wavelength. Here, to calculate the nu bar or 1 by lambda, this formula must be used. The unit of wave number is meter inverse. R in bracket 1 by n square minus 1 by m square. This is the formula. In the case of Lyman series, the electron jumps from any other outer orbit to the first orbit. Therefore, n must be taken as 1. Are you clear? Depends on the transition. You have to find out where from it comes down. If it comes down, if the transition is taking place from 2 to 1 means m must be taken as 2. If the electron jumps from third orbit to the first orbit, m must be taken as 3. So like that you can choose. The Ricbert constant value is also given here. Let's calculate the wave number and wavelength of the 2 major spectral line. Look at that. So when the electron jumps from the infinite orbit to the first orbit, that spectral line is called a series limit. There, the radiation will be emitted with the shortest wavelength. So the shortest wavelength in Lyman series, whose wave number and wavelength both of them must be calculated. What is the formula? Nu bar is equal to R 1 by n square minus 1 by m square. This is the general formula. So here, what is the value of n? N is equal to 1. So it jumps from infinity orbit to the first orbit. Substitute here. R 1 by 1 must be substituted. 1 square minus 1 by infinity square. Are you clear? So after calculation you will get nu bar as R. Here this value becomes 1. Are you clear? 1 by 1 is equal to 1. Therefore wave number is equal to R. To calculate the wavelength, what we have to do? Lambda is nothing but reciprocal of the wave number. Are you clear? So reciprocal of the wave number, that gives you 1 by R. So substitute the value of Ricbert constant, we are able to get the wavelength of the spectral line. This is called a series limit. In the same manner, we have to calculate the longer wavelength spectral line in the Lyman series. How to calculate? Same formula. Nu bar is equal to R 1 by n square minus 1 by m square. Substitute here. When the longer wavelength radiation will be emitted, when the electron jumps from second orbit to the first orbit, the longer wavelength radiation in this Lyman series will be emitted. Substitute here. How to choose the m and n value? N is already known, 1 square minus 1 by m. M is nothing but 2. 2 square. Nu bar is equal to R. 1 by 1 minus 1 by 4. Are you clear? So after simplification, you will get here R is equal to 1 minus 1 by 4, which is equal to, take LCM. So here if LCM is taken, what will happen? 4 minus 1. You will get the answer as 3 by 4 R. This is the value of wave number. How to calculate the wavelength? Wavelength is a reciprocal of the wave number. Therefore, lambda can be simply written as 4 divided by 3R. So, this is the formula. Substitute the value of R both in the two formulae. You are able to get the wave number and wavelength of the longer wavelength radiation in Lyman series. Okay. Very simple one, easy one. When the excited electron, when they jump from any other outer orbits to the second orbit, these spectral lines are emitted. These spectral lines are grouped and it is called as Balmer series. The spectral lines in the Balmer series, they will lie in visible region. This is the only spectral series which could be seen by our eye. Now we are going to calculate the wave number and wavelength of the series limit, that is shortest wavelength spectral line as well as longer wavelength spectral line in the case of Balmer series. When the shortest wavelength spectral line will be emitted, here the electron, it has to jump from infinite orbit to the second orbit. When the electron jumps from infinity orbit to the second orbit, the shortest wavelength spectral line will be emitted. That is called series limit. What is the formula to calculate the wave number? Nu bar is equal to R. I am going to substitute the values in the formula. Here n is equal to 2. Therefore 2 square minus 1 by infinity square. So after substitution the answer will become R. This factor becomes 0. So here you will be getting 1 by 4. So which is equal to R by 4, Ricbert constant divided by 4. How to calculate the wavelength? Wavelength is nothing but reciprocal of the wave number. Therefore this one could be written as 4 by R. Are you clear? By substituting R in both the two formulae, we are able to calculate the wave number as well as wavelength. Let's calculate the longer wavelength radiation. Its wavelength and frequency in Balmer series can be calculated here. How to calculate? Here nu bar is equal to R. In the formula, instead of 1 by n square we can substitute 2 square minus, after substituting 2 here, how to choose m? M is the next level excited state. Therefrom the electron it has to jump. Okay. Therefore 3 square. So that is the formula. After substituting you will get the answer 1 by R. So R is there. 1 by 4 minus 1 by 9. This value becomes 9. So R is equal to, this one factor becomes 36. Here this one becomes 9. Here you will get 4. So finally you will be getting 5 by 5R divided by 36 is the answer. This is the formula to calculate the wave number. How to get the wavelength? Wavelength will be equal to, just you reciprocate the wave number. You will get 36 divided by 5R. So this is the formula by which we are able to calculate the wavelength and wave number of the longer wavelength radiation in the case of Balmer series. Okay. When the excited electron, when it jumps from any other outer orbits to the third orbit, these spectral lines are emitted. For each transition, each spectral line will be emitted. These spectral lines are grouped as and named as Paschen series. The spectral lines in Paschen series, they will lie in infrared region. Now we are going to see about Paschen series. In Paschen series, we are going to calculate the wave number and wavelength of the shortest wavelength of the spectral line. Okay, that is called series limit. When the shortest wavelength radiation will be emitted, look at the transition takes place here. When the excited electron, when it is making the transition from infinity orbit to the third orbit, by the time the shortest wavelength radiation will be emitted. Therefore, m must be taken as infinity, and finally it reaches the third orbit, n is equal to 3. To calculate the wave number nu bar, which is equal to r 1 minus that formula to be used. Instead of n, substitute 3 square minus, instead of m we have to substitute infinity square. Are you clear? In the next step, how it can be written? Nu bar is equal to 1 by 9 minus 0. So finally we can write nu bar is equal to r by 9 can be written. So this is the formula to calculate the wave number. Okay. To calculate the wavelength of the emitted radiation, this nu bar must be reciprocated. Reciprocal of the wave number is lambda. Okay. So after reciprocation, how the formula can be altered? 9 by r is the formula. By substituting r here and there, we are able to calculate the wave number and wavelength of the which one? The shortest wavelength radiation emitted in the Paschen series. It is otherwise called the series limit. Now we are going to calculate the wave number and wavelength of the longer wavelength radiation. When the longer wavelength radiation will be emitted in the case of Paschen series, when the transition takes place between the fourth to that is third orbit. Are you clear? That is the nearby orbit from which the electron it is making the transition. Therefore, n is third. In the case of Paschen series, n is equal to 3. Here the transition takes place from fourth orbit to third orbit. So in the same formula, m and n both have to be substituted. So what is the formula? Nu bar is equal to r. So here instead of 1 by n square, substitute 3 square minus 1 by, instead of m, substitute 4 square. So after that what will happen? Nu bar is equal to r 1 by 9 minus 1 by 16 you will get. In the next step you will get the formula as, here you can write 144 here after multiplication. After taking LCM you will get 16 minus 9. That could be written within the bracket. Finally, we are able to get the expression as 16 minus 9. How much? Here you will get the answer as 7 divided by 144. 7 divided by 144 into r. So this is the expression to calculate the wave number. How to get the wavelength? Wavelength is nothing but reciprocal of the wave number. Okay, wavelength is nothing but reciprocal of the wave number. Therefore, finally you are able to write it as 144 divided by 7r. So this is the expression. If any problem or any 1 mark objective questions are asked, you should know how to calculate the things. Okay. So this is the details about the shortest wavelength radiation emitted in the Paschen series. This is the details about the longest wavelength emitted in the Paschen series. Okay. When the excited electron, when it jumps from any other outer orbits to the fourth orbit, these spectral lines are emitted. When these spectral lines are grouped and named as a series, it is called as bracket series. The spectral lines in the bracket series, they lie in the infrared region. Now we are going to see the fourth spectral series called bracket series, in which we are going to calculate the wavelength and wave number of the shorter wavelength radiation emitted in the bracket series. When the shorter wavelength radiation will be emitted, look at that. Here the electron transition that takes place from infinity orbit to fourth orbit. So therefore n is equal to 4, that m is taken as infinity. So already the formula is there, nu bar is equal to r, instead of n substitute 4, 1 by 4 square minus 1 by infinity square, this factor becomes 0, therefore nu bar is equal to r, 1 by 16 you will get, finally it could be written as r by 16. So this is the wave number formula for this transition. And then how to calculate the wavelength? Wavelength is nothing but reciprocal of the wave number. So reciprocate the value, you will get 16 by r. Are you clear? By knowing the value of r, Ricbert constant, we are able to calculate the wave number and wavelength of the which radiation? Shorter wavelength radiation. This is also called a series limit, that you should not forget. If any transition that takes place from infinity orbit to any orbit, that one is able to emit the shorter wavelength, that is otherwise called a series limit. Now next we are going to concentrate on the longer wavelength radiation emitted in the bracket series. When the longer wavelength radiation is emitted, when the electron's transition that takes place from fifth orbit to fourth orbit, the longer wavelength radiation is emitted. So how will you calculate? Nu bar is equal to r. So in bracket 1 by 4 square must be written, minus it comes from, the transition takes place from 5th to 4th. Therefore 1 by 5 square must be written. Are you clear? So nu bar is equal to r, 1 by 16 minus 1 by 25 could be written. So after calculation, you will get the answer as nu bar is equal to r, multiply both, you will get 400. 400 minus 6 divided by 16 is equal to 25. Minus 16 you will get. Okay. So here, after that what will happen? R is equal to R into 9 by 400 you can write. So this is the wave number formula for longer wavelength radiation. Therefrom we are able to get the formula for wavelength. Reciprocal of the wave number is equal to wavelength. Reciprocate this. So you will get 400 divided by 9r is the formula. So both are calculated here. Okay. When the excited electron, when they jump from any other outer orbits to the fifth orbit, these set of spectral lines are emitted from the hydrogen atom. These spectral lines are grouped and named as Fund series. The spectral line Fund series, they lie in the infrared region. The spectral series of hydrogen atom, now we are going to concentrate on the last series called Fund series. Here we are going to calculate the wavelength and wave number of the Fund series. Here, when the shorter wavelength radiation will be emitted, among all the radiations, the shorter wavelength radiation will be emitted when the electron transition takes place from infinity orbit to the fifth orbit. Therefore, the n value is 5. Transition that takes place from m is equal to infinity. Substitute here in the formula, nu bar is equal to r, 1 by 5 square minus infinity square. So finally we can get the formula as r into 1 by 25. So this one could be written as r divided by 25 is the formula. So this is the formula to calculate the wave number. How to calculate the wave length? Wavelength is nothing but reciprocal of the wave number. That is nothing but 25 divided by r. One thing I would like to insist that whenever you calculate the wavelength, you can easily remember that the Ricbert constant will be in the denominator. In the case of wave number R, Ricbert constant will be in the numerator. So like that you can keep all those things in remembrance. Okay. So let's go to the next one, longer wavelength radiation. When the longer wavelength radiation will takes place, when the electron jumps from the nearest orbit, from 6th orbit to the 5th orbit, the longer wavelength radiation will be emitted in the case of Fund series. So therefore, n is equal to 5. Here electron finally it reaches here. Where from it comes? M is equal to 6. Okay. So what is the formula to calculate the wave number? Wave number is equal to R. The same formula. Instead of n, substitute 5 square minus 1 by 6 square must be written. Nu bar is equal to R 1 by 25 minus 1 by 36 you will get. Okay. So here both the two values must be multiplied. 25 into 36 is equal to 900. Okay. So the next step we can write it as nu bar is equal to 900. You can write after taking LCM 36 minus 25 must be written. So if it is subtracted you will get 11. 11 divided by 900 into R you will get. How to calculate the wavelength? Wavelength is the reciprocal of the wave number. Therefore 900 divided by 11R you will get. So both are calculated here. This is about the shorter wavelength, that is about the longer wavelength. Okay. So I have explained all the series in a very detailed manner. So here just we have calculated the two extreme things. If you want to calculate the wave number or wavelength of any transition in any series, so clear you should know where from the electron transition takes place. For example, in this particular Fund series, if you want to calculate the second spectral line, are you clear? Second spectral line means which one? This is the first spectral line. 6th to 5th is called first spectral line. Second spectral line in Fund series means, so clear, 7th to 5th. The transition is called second spectral line. So like that, so clear you should know the value of M and N. Substitute the appropriate value. We are able to calculate the wavelength and also the wave number of any spectral line in any series that could be found. Okay, thank you.